Problem number 47. I won't read everything here, but the goal is that you want to build an enclosure that consists of two identical rectangular pens here. You have 840 feet of fencing, and let X be the vertical length, Y be the horizontal width of each pen here. Okay, so let's figure out what's going on. So if this is X, this length is also X, this length is also X, this length here is Y, this length here is Y. So what is the overall, how much fence do we use in terms of X and Y? We use 1, 2, 3, 3X plus 1, 2, 3, 4 plus 4Y. This is the total length. The area is going to be X times Y plus Y is going to equal X times 2Y is 2XY. So in part A says that we want to find area of one individual pen as a function of X. We need to write this as function X as a function of both X and Y here. So we need to replace Y with something in terms of X. And we're going to do that through the fact that we know that we have 840 feet of fencing. So 840 is equal to 3X plus 4Y. So solving this for Y in terms of X, 4Y is equal to 840 minus 3X. Y is equal to 840 minus 3X divided by 4. So what is the area here? It's 2. So this is Y in terms of X is 2 times X times 840 minus 3X divided by 4. Which we can simplify to X times 840 minus 3X divided by 2. For part B says, suppose that for each of the two pens, the sum of the length and the width must not exceed 250 feet. So that is saying sum of the length and the width, we want X plus Y to be at most 250. Okay, so then the question then becomes, it says here, what is the domain of F? What is the domain of F? What allowable X values can we think about here? So the first thing is that we should realize is that we want X to be non-negative. In fact, you could say here, depending on how you interpret this, X needs to be strictly positive, or else, this doesn't, or else this probably really doesn't make physical sense. We also know that this expression here for Y, we also need 840 minus 3X. We need this to be strictly positive or else Y ends up at 0. And then finally, X plus Y is less than or equal to 250. Well, let's replace Y with this in terms of X. X plus 840 minus 3X over 4 needs to be less than 250. Okay, so let's go ahead and solve these inequalities, think about what's going on here. Multiplying everything here by 4x plus 840 minus 3x is less than or equal to 1,000. That's x minus 3x is just, 4x minus 3x is just x. Subtract 140 from each side. X is less than or equal to 160. Over here, this tells us that 840 needs to be bigger than 3x, or x is less than 840 divided by 3, and 840 divided by 3 is 280. So x needs to be positive, less than or equal to 160, less than 280. This one here is irrelevant. In fact, it's less than or equal to 160. This is certainly true. So our domain here is x is strictly positive, less than 160. If you wrote that it also includes 0, that's probably an okay answer as well. It depends on how you interpret things. In any case, for the problems later on, that we will need this kind of thing for when we do calculus with this, it really shouldn't come up too much. Okay, that's problem 48. Sorry, that's problem 47. Problem 48 here. The last one. If you made it through all these videos, my hat is off to you. F of x is the square root of 9x to the 6 minus 7 over 2x cubed. We want to find the limit as x goes to infinity and the limit as x goes to negative infinity. This is actually asking us for horizontal asymptotes. Okay, so I'm going to, before we do anything else here, going to do a little bit of manipulation here. I want to factor out x to the 6 out from this. So under the square root. So this is going to be x to the 6 times 9 minus 7 over x to the 6. All that over 2x cubed. And what's the square root of x to the 6? The square root of x to the 6 is going to equal one of two things. It could just be x cubed. Your temptation is probably just say, oh, square root of x6 is x cubed. But this is true only if x is non-negative. If x is negative, it's the negative of x cubed. Just to illustrate this here with an example, if x is negative 2, then the square root of negative 2 to the 6 is the square root of negative 2 to the 6 is going to be 64. Square root of 64 is 8. And x cubed, negative 2 cubed, is negative 8. So we need negative of negative 2 cubed to give us plus 8. So when I ask you about the limit as x goes to infinity of f of x, limit as x goes to infinity, x is positive, so we can replace the square root of x6 with x cubed. And so then these cancel. Square root of 9 minus 7x to the 6 over 2. As x goes to infinity, this goes to 0. So we end up with square root of 9 minus 0 over 2 is 3/2. Now, for the limit as x goes to negative infinity of f of x, x is negative here, so we need to replace the square root of x6 with negative x cubed. And so in this case, those cancel, and I'll skip a step or two, you end up with negative 3/2. So 3/2 and negative 3/2. The moral of the story here, you need to be careful with square roots. You need to be careful here with square roots. So I didn't say this, but if I asked about horizontal asymptotes, this is y is equal to 3/2, y is equal to negative 3/2.